So far we have been implementing trajectory following by simply following a line printed on the floor. We will now look into techniques to implement reactive trajectory following if the position of the robot is known and you have a waypoint that you want to drive to. In this case, I have an orange that always moves to the next waypoint, and as you can see, the robot is slowing down as it approaches the waypoint and also turns faster when the angular error is large, and then turns slower and slower until it finds the heading of the object. We will now implement this on the map that you're already familiar with, and then have a homework assignment where you will implement trajectory following on the Thiago Steel robot, as well as mapping the environment going around this table from both directions, so you will actually see not only one side of the obstacles but also the other, and then create a C-space of this environment that we can use in the next course. In order to implement a trajectory follower, we will take the line following world that we already have, and I assume you also have a line following controller, and what we should do is we should save it as a new world, which we might call trajectory follower, and we will also create a new controller. For this I used the wizard new robot controller. We want to do this in Python. Call it trajectory follower, and we want to make sure that this is in the line following project. Alright, now let's copy and paste the line following controller into the trajectory follower and save it. And now we also have to change it here in the epoch scene tree window. And here is the trajectory follower. Alright, so what we want to do is we want to create a set of waypoints and have the robot drive around this circle using the waypoints instead of using the lines on the floor. For that, we should also do something like you seen earlier, where I used the orange for showing where the waypoint is. This makes things much easier to debug, and in this world you can use a ping pong ball and place it somewhere in the environment. Now let's place it just here, and now we enter a def name, let's say marker, so that we can access it in the scene tree. Now what you can do is you can turn the robot in what is known as a supervisor in Webots. That will give the robot a little more features, such as interacting with the environment. In order to do this, we should also import supervisor here, and now your robot has additional capabilities. We need to also tick the supervisor field here so that the robot knows that it has access to these functions. And now we can actually control the position of the ping pong ball. I encourage you to read up the supervisor documentation online. We can now retrieve a handle to this object, let's call it marker, and use the new functionality from the supervisor. And in particular, we have a function called getNodeFromDef, and now we can provide the name that we have entered here. So we have the definition marker here, and this should work. When you run this, it should just compile. Of course, nothing happens because we haven't done anything yet. And what we now can do is we can extend this and get a specific field from this node, and what we want to get is the translation field. So you see, this is the field name translation. We can now access those fields directly, and for that Webots has a little bit cryptic commands set, and then it is SF for single field, and we want to set a vector with 3 floats. And again, have a look at the documentation to learn more about all the different options that there are. Now we want to provide 3 floats, and in this case we give the position of the robot, so 0, 0, put the ping pong ball right there, but maybe we can have it floating a little bit on top and see what happens. And now, as you can see, the ping pong ball is indeed there, and now it falls, and we can use functions like this to just move the ping pong ball around as the robot drives.